Hello everyone, myself Dr. Jyoti Mandala. Welcome you all to the video lecture series on the course Operating Systems. So up to our last lecture we learned about introduction concepts about operating system, where we learned what actually an operating system is, what are all the different types of operating systems we have, and also we have learned about what is nothing but a system call and what are all the different types of system calls we have. I hope you all are clear with those basic concepts. So from today onwards, let us learn one of the important operating system service, that is process management. Okay, so we are going to learn multiple concepts under this process management. So this is one of the important service that is provided by the operating system. Okay, so while learning about operating system services in brief, we have listed this one as one of the service provided. Okay, so let us start learning about this process management. I hope you all can recollect, like while understanding the process management there as part of operating system services, I told you like what actually a process is. Again, I'll repeat that process is nothing but a program under execution. Okay, so let me write down the definition. Process. Process is nothing but a program under execution. So whenever you have a program, let us consider you have written one Java program or any program. Okay, that program, once you type and once you save that program, then what happens, that program will be stored in your hard disk. Okay, once it is stored in the hard disk, now you want to execute that program. Now whenever you want to execute that program has to be copied from the hard disk to the main memory. That means always remember, whenever we want to execute any program, like whenever we want the CPU to execute your program, that program should be available in the main memory, isn't it or not? Then our program, once we type and save that one, that will be stored in the hard disk only, secondary memory only. But whenever we want to execute, OS will copy the program from secondary memory to main memory. Now once it is copied into the main memory, then the program will be considered as a process. I hope you are understanding. You are writing a program and saving that one in the memory, then at that till that time it will be considered as a program only. But once it is copied from your secondary memory to the main memory, telling like it wants to execute the program and it is waiting for the CPU time to get executed, then we are telling like that program will be considered as a process. I hope you all are understanding. That means why we are copying the program, why the operating system is copying the program into main memory, only when we want the program to be executed. That means the CPU can access only the main memory, right? So as the CPU can access only the main memory, we need to copy, that means the operating system need to copy the programs from the secondary memory to the main memory. That means you can understand in another fashion, your program is considered as a passive element. Program is passive element, but whenever you are converting that one to a process, that means whenever it is copied into the main memory, then it is referred as a process. Then process is your active element. I hope now it is clear to you. So passive element means it is in the secondary memory. Okay, passive element means it is in the main memory. Why it is waiting in the main memory? Because it wants to be executed, so waiting for CPU to get executed. Got it? Now once a program is copied into the main memory, then in what format it will be stored in the main memory, that we are going to learn today. Okay, so let us see now what is a process representation in the main memory. That means how the process, I am telling here, the operating system will be copying the program from the secondary memory to the main memory. Now once it is copied into the main memory, how the process will be copied into the memory, what sort of data will be maintained into the main memory relating to that process, everything information will be stored in a particular format. That format we'll see now. Got it? So let us see that format. I hope you all are clear with the basic introduction to what is process and all. So you can see here I am showing one format. So this is the format that is applicable for each and every process, where this type of format will be maintained by the operating system in the memory itself. In the memory, this format will be there. In the memory, this format will be available. In this format, for each and every process, the data will be stored. Got it? I hope you all are understanding. That means you see, let us consider one process P1. For that process, all this information, text, data, heap, stack will be contained. For process P2, again text, data, heap, stack, like that the data will be stored. Understood all of you? Now let us see in detail about what are all these things for each and individual process. Okay, note down this diagram. All of you will have a clear idea about each and individual what each individual parameter that is reflecting here. Will have a clear idea about that. Okay. So here you can observe in the memory, the 0 and max represents the minimum address value and the maximum address value. The maximum address value we cannot fix. It depends upon your memory size. Okay, so that's why it is represented as max there. It can be, it differs from the memory, what size of memory we are using. Okay, now let us see. So 0 represents the minimum size, max represents the maximum size. Now we'll see about this text, what actually this text is. Text is nothing but it talks about the program code. Whatever program you are writing, let us consider for addition of two numbers, you may be writing some set of instructions, isn't it or not? Those set of instructions are referred to as a program. So text contains all the programs that you have. So write down here code. Whatever code you write here, that will be reflecting here. Or you can also say as instructions, set of instructions. Okay, so to perform the particular task or to whatever instructions you want to execute, that will be reflected here. That is talked about, that is placed in this place, which is referred as a text. Okay, so always this refers to your code segment. Okay. Now coming to the data, what is this data? Data stores a global variable. See, in your program you already know what actually global variable is. Global variable is nothing but, if you have your C program, if you have multiple functions in that, and if you want a variable to be used in all the functions, that means it has to be uniformly used by all the functions, then you will make that variable as a global variable. Isn't it or not? Similarly, you have in the Java programming language static variable. What do you mean by static variable? It will be created once and it can be used by multiple objects. Isn't it or not? Okay, so such a thing, if you want to create global variables or if you want to create static variables, then that data will be stored. That data, whenever you want to store the global variables, all static variables are there in your program, then that data will be stored in this part, which is referred as a data. Okay, you can make a note of that one. What is that? Global variables. Static variables. Alright, coming to the next one, which is represented as heap. Now what is this heap? Heap is nothing but this stores all the information, like all the variables information. Okay, let us consider the variables information like which requires to be initialized at runtime. Are you following? Well, at the time of runtime, if you want to allocate the memory for the variables, then such variables are stored here, that in the heap part. So okay, this stores the variables. This stores those variables that requires the memory to be allocated at runtime, which is also called as dynamic memory allocation. Okay, so dynamic memory allocation will be done for pointers whenever we are using. So pointer variables can be stored here. Okay, so whenever we want to allocate variables which requires memory to be allocated at runtime. Okay, or else you can note down like it is dynamic memory allocation. Okay, the variables which requires to allocate memory to be allocated dynamically at the time of runtime, such variables should be allocated here. I hope you all are following. Coming to the next one, that is stack variables. What is this stack variable? Stack variable is nothing but this is also referred as a function stack. Suppose if you have multiple functions in your program, then that function may be having its own function parameters which are to be used in the program. Okay, or it can or like it can be having its local variables. Okay, and also we may be calling one function can be calling the another function. Then in that case we may have a return address from where it has been called. It has to return back. Once the function is executed, it has to return back to its original function from where it has been called, isn't it or not? So such information will be stored in this part which is referred as a stack. So this is also referred as a function stack. Okay, so what sort of information will be stored here? Function parameters, which are used within the function, and you can say return address of the function from where it has been called. It has to return back, go back to that place only. Okay, and another one is like you can say local variables. Local variables means the variables which are used within that function. So such information will be stored in the this stack area. Got it? Understand here one point. Whenever we are using stack, no, the stack will always increase, like go towards the down direction, and the heap always goes toward the upward direction as per the requirements. If this is more, if you want to have the size to be decreased, understand, from top to bottom we are decreasing the thing. So in this fashion, the stack, if you want to decrease, you can go like this. Suppose if you want to increase, it should go like from the top to bottom. Got it? So always heap will move upward direction and the stack will move in the downward direction. Right? So let me quickly revise this one once again. So text field contains, what the text field contains? Text field contains the program that you want to store, the instructions, all the code like C program, whatever you are writing, complete instructions will be stored here. That program related global variables or static variables will be copied here. And heap, what it will contain? At the runtime, whatever variables data you want to store, that will be stored in this heap part. Okay, in the stack, it will be containing the function information, its return address, okay, its local variables, its function parameters. For the function, whenever you are calling no parameters to be passed, so those function parameters, local variables, its return address, all this thing will be stored. So this is relating to one particular process. Okay, now for each and every process like this, the data will be maintained. But here understand, there may be a chance like 2 or more processes may be associated with a same program. Okay, P1 and P2 you consider 2 processes. P1 and P2 both are associated with the same process. In that case, let one example let me tell you. A same user may be invoking multiple copies of web browser. Okay, web browser programs, multiple copies, you are executing multiple times that web browser code. Then it is not this thing like it will be same, the same memory will be allocated. No, the text may be same, that means the program code segment may be same, but the data, heap, stack components, whatever we have, that may vary. Okay, so here you need to understand, although two or more processes associate with a same code, they are considered as separate execution sequence. I hope this point is clear to you. What is this point talking about? This point says like if a single user is working makes a copies of web browser, then in that case it is not like all the web browsers are referring to the same memory location. They are stored in the memory with a simple structure like this. No, They are considered as individual things. Even though the text, the program segment is same, the data heap and stack whatever we are storing, no, that is different. So you need to understand this point. Okay, so this is about a little bit introduction about what is process and how the data, like how the process will be represented in the memory. So for this diagram you can make a heading like process representation in memory. Okay, so this is how process representation in memory. Which memory? Which memory? It is in main memory. Okay, because when it is called as a process, it will be called as a process only when it is copied into the main memory. Got it, all of you? So I hope you all are clear with this concept of process management. Let us all meet in the next lecture, where in the next lecture we'll see about the different states that a process can traverse through. Okay, so let us all meet in the next lecture. Until then, thank you all of you.